First of all, this is day 4 of notes. This is your last day. We will complete the packet. The only thing that you will not be tested on, which you have voted to be next week, will be odd and even functions that is in your notes packet. Everything else will be online in some way, shape, or form, and it will be tested. If we do have time, which I think we will, the last 2 pages, basically the last page front and back of your notes, if we have time, we'll get to it. If we don't, I will record those and post them online. It won't be a net puzzle, but it'll be for you to be able to view so that you know, understand what's going on. Now, let's talk real quick. Next time we meet, instead of a CFA, it will be a quiz grade. So it will be 3 times of what a CFA would normally be. It will be on WebAssign, and it will basically be up to including the first half of today's notes. So basically, think of it as a little bit of a premonition of the level of difficulty of the test that you will have next week. Not a direct reflection, but a little bit of a, okay, I see what we're gonna, how the questions are gonna be asked. So you have a quiz next week. We'll have homework due on Sunday. This will be the last to help prepare you in regards for the test, and then you'll have your test next Monday. Test being next Monday, I think it's a good choice because there's a lot of people saying that there's a lot of teachers testing this week, so that you don't have 4 or 5 tests in one day. It kind of gives you a little bit of a break, knowing, okay, I can just concentrate on a couple, whatever, for next week. Take the test. The only bad thing is we lose the review day for the final exam. But if you're only counting on the review day for the final exam to review you for the final exam, it's going to hurt. That grade is going to hurt the final exam itself. So you should start to, this week, be looking at those questions. I did post them on Google Drive. All the questions are there in paper format if you just want to start doing the problems themselves. I also posted on Google Drive, what's it called, a formulas chart. Formula list. So it's 4 pages, but it's for the whole year. All you're concerned is 2 pages for the first semester. So anything on the first 2 pages of that formula list, that's basically, in a nutshell, a good summarization of, wow, we did a lot over just this one semester. That's going to be a good cheat sheet for you that brings everything together as far as definitions, theorems, and all that good stuff. All right, so let's go ahead and get started. At the end of today's notes, you will be able to graph a lot more accurately. There's no guessing game, and you'll understand a little bit more as far as what you were intuitively using as far as frown and smiles that we were doing of curves and stuff before. Here we go. A little bit of review. I think we got to this, and if we did, no worries. I just wanted to start with this anyway, just to get your brain going. If I'm looking at a f prime graph, and I'm wanting to know when f of x is increasing, the analogy that I used this morning helped a lot. So the analogy that I used before were when people, like if I wanted to meet someone, but someone was telling me about them, I never really met them, but I was getting my information from f prime, I could picture a little bit of what f of x looked like. The analogy I gave this morning helped a little bit more if you've seen the movie Inception. Have you seen the movie Inception? If you have, please raise your hand. So it's a movie about this. Here's reality, like think of reality as being where you're at right now, and then you fall into a deep sleep, and in that sleep, things are happening. You, if it's a vivid dream, you think it's real. But if you know you're dreaming, you at least know, okay, I'm dreaming right now, but my body is, lying in bed, hopefully not falling off the bed or whatever. But you know what I'm saying? So think of f prime of x as the first level of dream that you're in. Everything that you see in f prime of x is telling you what's going on in reality. So reality being where your body is at in f of x. So if f prime of x, this is just an example, if f prime is negative, f of x is doing what? Decreasing. So in reality, you could say you're falling off your bed. You know what I mean? If in your derivative dream f prime of x is negative, in reality you're falling off the bed or whatever. You're falling. Okay? That's a good way to look at it if you still haven't looked at it the other way and understood it fully. So with that being said, if I want to know when f of x is increasing or decreasing, I'm going to analyze this f prime of x function. If it's negative, that's when it's decreasing. If it's positive, this is when it's increasing. What did we call this from before? Critical point, because it's equal to 0, but what kind of critical point did it yield? a relative what? Maximum or minimum?
That's a relative.
It's a relative min. What's its? Because f prime of x changes. So at x is equal to negative 3 and 4, because f prime of x changes signs, or just changes from negative to positive. And then relative max, anyone? X is equal to 1 because f prime of x changes from positive to negative. Alright, estimate, we've already done that. Justify your answer, we already did that. The only thing that I need to write for justification to get full credit, first of all, let's write this part. I think you already have it in your notes. F of x increases on negative 3 to 1 union 4 to infinity. And then f of x decreases on negative infinity to negative 3 union 1 to 4. Perfect. Now, what is the first derivative test aim? Look in your notes real quick. What is the first derivative test aim to show you? In that box that has the first derivative test, what information surrounded it with the first derivative test? It aimed to find this. So I will say per first derivative test, my relative max and mins are this because of, so the justification is here. Please don't put per first derivative test here because the first derivative test doesn't show whether it's increasing or decreasing. We use the first derivative to analyze that, but that's not the first derivative test. The first derivative test, in retrospect, and in retrospect at the end of the period, you'll understand what I'm saying. The first derivative test aims to find one of those, as does the second derivative test. So the second derivative test, which you'll learn at the end of today's notes, also aim to find relative min and maxes, but in a different way. Okay? Here we go. Now, in your note, did we do this last time? Okay, so in your groups. Alright, so now to work this out, the very first thing that I want you to get accustomed is, what are you being asked? You're being asked to find what is the sign of the derivative at negative 1 on the g function. Okay, so we are given a g position function, and the first thing that we need to do is derive it. So constant multiple rule out the 2, and then multiply it back in, and this is the derivative that I'm looking for. All I need to do now is plug in negative 1, because that's my at value, and then I'll figure out what the number is. So if I put in f prime of negative 1, so at negative 1, which is in this interval, what is the derivative? It's positive. So 2 times a positive, your answer is a positive here. Okay? So here, again, you're being asked to find what is g prime of something. Always derive first and then plug in. This is what rule? Chain. This is the chain rule. So the chain rule says I'm going to take the derivative of the outside and then multiply by 3. So it's f prime of the stuff and then times the derivative of the chain. So if I plugged in now negative 1 here, I get negative 8. This exists in this interval where the derivative is negative. So 3 times a negative, your answer for this one is negative. So everyone got that correct? Okay? Because this right here is chain rule. It's f prime of the stuff times the derivative of the stuff, which is 3. Alright, here we go. Alright, next one is a real-world application problem. Okay, so I'm going to intermittently ask you, please let me know what the answer is. If you have any questions, do by all means ask. This is a position function. It describes the location of a particle in motion. Okay, those of you in physics, this is probably going to be really easy for you, no worries. Find the velocity when time is greater than or equal to 0. And I'm trying to find the velocity function. So what is it that we have to do? Just derive. Because this is position. I can write it like this, or I can write it with a v, because they both mean the same thing. And that's it. There's my answer, 2t minus 7. Pretty simple. Then it says, identify the time interval or intervals where this particle is moving in a positive direction. What's your intuition telling you that means? What is the sign test? You're right, sign test, but what's important about positive direction? When the derivative is positive. If the derivative is positive, look, there's 3 ways you can be positive derivative. You can be moving in forward in a positive direction. You can throw a particle upward, that is a positive direction, or on a graph it's moving to the right. Okay? So here we go. I'm going to set the derivative equal to 0, which I'm going to say 0 is equal to 2t minus 7. And then I'm going to solve for t, my critical point. And anyone, what is that? 7 halves. So you go over here, create your 7 halves. This is f prime of x. Anyone pick a number in the first interval? 0. Put 0 in here. What's the sign? Negative. Could I pick -1?
Yes. No, you wouldn't
Nope.
want to, because it's
Because there's no point, there's no such thing as negative time in this context. Okay? So let's pick something to the right of 3, or
1.
no, to the right of 7 halves.
Oh.
4. So 8 minus 7, the sign is positive. So your answer is this. Moving in a positive direction on 7 halves to infinity. Open or closed? Open. Okay? Because 7 halves is equal to 0. What's the sign of 0? It's not positive nor negative. Okay? So it has to be positive explicitly for you to say I'm moving forward in that interval. So yes, this is very important, especially on that piece right there. And you're going to see here in just a minute why. Justification, because f prime of x is positive. Now, I know this is an s prime of x or s prime of t. If you put f prime of x, I'm not going to count it wrong. If you put f double prime, I'd count it wrong. But f prime of x, I'm just going to say that you misspelled s and you misspelled t. Okay, but you got it right.
So, wait, would that work on AP test?
Yeah, they do that too.
You plug back into the original equation, not the derived equation?
No. You're going to plug this into the derived equation because you're trying to see what's the sign of the derivative.
Okay.
So here we go. When is it moving to the negative direction? What would my answer be from what you see? Not a negative infinity. We cannot have negative time. Okay, so 0 to 7 halves. Close or open? Open on what? Not both. Closed at 0. Now, I've told you, when you get questions that ask you when something is increasing or decreasing, always have it open. Now, you know this is a form of increasing or decreasing, but it didn't explicitly ask, is it increasing or decreasing? It just says, is it moving in a negative or positive direction? Why can I close it on 0?
Because because you can't have negative time.
No, not because of that.
It tells you that.
Is it because it tells you?
Because of this? You're saying because of that right there?
Time starts.
Not because of that. Because when I plug in 0 into my derivative, what answer do I get? A negative. That is moving backwards. What does that mean in real life? That means when I started the stopwatch, that particle was already moving. It didn't start from a velocity of 0 and then start to take off. I saw this thing moving and I wanted to clock it right here as it was already moving. Do you understand? That's the subtle difference, and that's a huge application of why you can close that bound. Not because of this here, but because it gives you and yields a negative value at 0. Do You understand? And that means the particle was already moving when you started recording data. Okay. So we would put because f prime of x or s prime of t is negative. None of this is per first derivative test. Still, because per first derivative test, again, what did we aim to find with first derivative test? Nope. Nope.
No, relative.
Relative max and mins. What do we aim to find with the second derivative test?
The same thing, but in a different
Same thing, but in a different way. Okay, so here we go. Identify the times at which the particle changes direction. T is equal to what? 7/2 what? We don't know. Well, we'll have to write something. Units of time. If you don't have seconds, if you don't have hours, please put this on your test. Units of time is your default if you're not given anything. Units of time because what? Not because it's equal to 0. A lot of people think that. Because around that it changes. Because at x is equal to 7/2, f prime of x is changing from positive to negative or negative to positive. It didn't say, hey, a specific change of direction from backward to forward. No, it just says change of direction. So you don't have to be as descriptive with your positive to negative or negative to positive. Because f prime of x changes signs around t is equal to 7/2. You know what I mean? It's changing from a negative to a positive. So technically this is what's happening. At time 0, what's my velocity? -7 units per second or units per time. Right? So it's already moving backwards when I start the timer. It's still moving backwards. When I get to 7.5 seconds or 7.5 hours, whatever the units of time is, what is it doing at 7/2? It's not moving. It stopped. Because what's the velocity? 0. Then it starts again into the positive direction forevermore. Okay? Alright, we were going to do a unit when we come back from Christmas over particles in motion in depth. Okay? This is just a little bit of intro into it. Here we go. New stuff. Concavity and second derivative. This is a definition that a lot of people confuse with second derivative test. Okay? And only because you're going to also use the second derivative to find it. Now don't get confused. First thing what I want you to do is I want you to put not the second derivative test. And even in college, when you go to college and you ask other students that are in your Calc 2 class that have already taken Calc 1, a lot of them still have this confused. The second derivative test is not the same as tested concavity or the definition of concavity, okay? So here we go. Let f be a differentiable function on an open interval. So it's continuous, right? The graph of f is concave upward. And what does concave upward mean? I've already introduced this to you. We trial and errored before, and now we're going to be very definitive, and it's going to be very easy for you to figure this out graph-wise. Concave up is a smile. It can be half of a smile, or it can be this other half of the smile. Okay? Concave down is a frown. Half of a frown, or this half of a frown. So there's no more guessing. This will tell you exactly what to do. Now, f prime of x is what on the interval? How'd you know that so fast? What are you thinking?
Every time it's increasing, you have a smile.
Okay. Decreasing. You're going to see why. I don't know. We'll see if we give it to him in a minute. Ready? If f prime of x is increasing, then on that interval it's concave upward. So in other words, over here when I gave you that f prime of x graph right here, it will be concave up on this entire interval right there. And it will be concave up on this interval. Why? Because f prime of x is increasing. If f prime of x is decreasing, then it will be concave down on that interval. Okay, so let's go to,
So you're doing that from the max and midpoints, is that what this is more like?
okay, yeah, yes, from the f prime graph, okay? All right, so f prime of x increasing is the same as f double prime being positive. Okay, those are synonymous. F prime of x decreasing, so these match up, is the same as the f double prime being negative. I'm about to give you this chart. It will help you a lot. Let's see if you understand it as we go through, but let's finish this blank first. If f double prime is positive for all x's in an interval, then the graph of f, 2 jumps up, is what? Concave up. And then concave down for the other one. Guys, you got to know both, okay? Not just one. From the 2 that I have right now, which one do you feel is easier to interpret concavity up or down? Which one? Like increasing f prime of x? Which one do you think is easier if I want to know if it's concave up? To me, I think that. If f double prime is positive, f, 2 levels up, is going to be concave up. If f prime is increasing 1 level up, it's going to be concave up. Do you understand? But for me, this one is the easier one to interpret, but we need to know both. Let me show you this table that I want you to put on your notes very neatly somewhere of how it relates everything. Here we go. F of x, f prime of x, f double prime. Okay? And we will say, this is what I want you to know. If f prime of x is, if f prime of x is positive, what do we say about f of x? It's what? It's increasing. It's increasing. If f prime of x is negative, what do we say about f of x? Decreasing. And f prime of x is 0, what do we say about f of x? Constant. Good. How many levels of derivatives exist between those 2 lines that I just did? Just 1. We're going to take that same concept and we're going to shift them down 1 line, okay? Both of them down 1 line. So a different color. Let's say that f double prime is positive. What does that say about f prime? It's increasing. You see that? It's the same thing. Let's call that first derivative looking at the positive or negative. Negative, it's decreasing. 0, it would be what? Constant. The only thing that we get to do with the f double prime is we get to jump 1 more level up and say this is concave what? Up. This is concave down, and then this one is what? It's neither. When can something be neither?
If it's a straight line, there's a cusp.
Okay, to say a straight line, a cusp, an asymptote, and a vertical tangent. Nice. So keep or ask me any questions that you have right now in regards to what the chart that I just gave you. Do you have anything? All the while you're using first derivative knowledge to see the relationships that occur between those different levels of derivatives. Yes, Scott.
So you can relate f of x, or you can relate f double prime of x to f of x. Can you like do the other way?
Can you do the other way? How?
Like, does it have any like, so for f double prime of x, is it only going to be like positive, negative, and 0 rather than, unless you go to f triple prime, then it would be like increasing, decreasing?
Yeah. If you do, that was a good question. If you do f triple prime, and f triple prime is positive, that doesn't show concavity of any kind. That doesn't show increasing of any kind. All you can do, his question was this, is f triple prime, no one asked this yet, was positive and negative and 0. The only thing you can interpret is the fact that f double prime would be what? Increasing, decreasing, and constant. That's it. But you cannot, That's a good question, because a lot of people think that you cannot show, ooh, there's going to be some concavity of some sort that can exist. But here's why that's a good question. What if on the test I ask you, what is the maximum acceleration? Did I already ask you this? What is the maximum acceleration of this function? What would you do to find the maximum acceleration of a function? That is, and I asked you the acceleration function. What would you do? You have to, and I gave you f of x. You have to derive how many times? 3. You need to derive all the way to the third derivative, because then you will analyze what you're trying to maximize. You will analyze this level. You would try to look for that relationship. When does the f triple prime change from a positive to a negative? That tells you the relative max of f double prime. Using what? What's your justification? Wait, what? First derivative test. First derivative test aims to find those relative max and mins by using one level of derivative from whatever you're trying to maximize or minimize. That's huge on the unit when we come back from Christmas, okay? We're going to be optimizing. Remember that project y'all did with Mrs. Hamilton? It was like a 3D box, and you're trying to maximize the volume. And you only did it because you had the factors of that cubic function, and you put it in your calculator. Well, now you can do it because if you have the factors and you find the critical numbers, you can see where they exist without even touching the calculator. Okay? All right, here we go. Next part. These blanks will give you good points. We'll see if you can answer them here in just a bit. If something or something, and the second derivative changes signs from positive to negative, or negative to positive, or f prime of x changes from what? Increasing to decreasing, or decreasing to increasing. A lot of people struggle with this, and you'll definitely see it on your final for sure. So just don't dismiss it, but at the same time, if you need to relate to this one, it's easier to interpret just for the answer. Alright, so this is called a definition of inflection point. A point of inflection. Go ahead.
What was that? What were you talking about?
Yeah, that's what we were talking about last time.
Friday?
A point of inflection changes when the derivative, the second derivative, changes signs. Because if I have positive to negative, I have concave up to concave down, there's a point of inflection.
So is that in between the...
That's in between the what?
The critical points? No, not the critical points, the relative.
Between the, remember we said there's not an alternating pattern. Ooh, I start with decreasing, it's going to be increasing, decreasing, increasing, decreasing. We did a graph last time that went decreasing, decreasing, and there was a critical point right here. This shows decreasing to decreasing. And in between, this changed from a positive to a negative as far as the double prime. What graph did I just graph? F double prime, or F prime?
F double prime?
Say again?
F double prime?
Nope.
F prime.
Just F. I just
Oh, yeah.
graphed F.
'Cause you
Concave
used
up to concave down with a point of inflection that exists in between. Correct. So the other one is negative to positive. Concave down to concave up. You with me? Alright, so points of inflection. This one looks like it has a slope of what? 0. Does it have to be 0? No. It could be something else. It could be 1, negative 1/2, whatever. This looks like it has a slope of what? Undefined, but it does not have to be undefined. It could be an actual quantitative number, like 1,000 or 20, whatever. You know what I mean? All right, so here we go. With this knowledge now of the first and second derivative, I want you to look at the F graph and tell me what is the sign between 0 and 3. Okay, so between 0 and 3 non-inclusive, What's the sign of the first derivative anyway?
Wait,
Negative.
It's negative because it's decreasing. F prime of x on 0 to 3 is negative, or you can write it like this, f prime of x is negative on 0 to 3, however you wanted to write it, because, what? Say it, Mackenzie, and I'll give you points, because what's decreasing?
F of X.
F of x is decreasing. F of x is decreasing. Okay? Let me see, f double prime, what is it?
Positive.
Positive because it's
Concave.
concave up. So f double prime is positive, or you want to write it like this, you can, on 0 to 3, because what? Because what is? Because what is concave up? F of x. Because f of x is, and guys, you don't have to write concave. They'll understand on the AP exam if you do that. Okay? Because f of x is concave up. Okay? You'll see a lot of the graphs, just caveat, a lot of people struggle with the graphs. But they're really not that difficult if you understand the rules. Alright, here we go. Your first actual problem that's very reflective of the level of difficulty on the test as far as how many things you're going to be asked. Okay? Second to the last page, I think there's 7 parts to a question. That's the level of difficulty that you'll see on the test. So here we go. But it's not that bad. You just got to get your definitions and theorems in order. I'm trying to find this. Here we go. Look up here, please. Brianna. The intervals where f is increasing or decreasing, what do I do? Hold on. Brianna, what do I do from here? I'm trying to find where f of x is increasing or decreasing. Up or out?
so you find the derivative,
Find the derivative. Keep talking, just you. Find the derivative, which is?
4x cubed minus 12x squared.
And what do I do? Keep going.
Then do put that equal to 0.
Set it equal to 0, but what else do I do on the right side of that? Factor it to what? You tell me.
It's gonna be 4x squared, then parentheses x minus 3.
Perfect. Taylor, what are the critical points?
Critical points is 0 and 3.
Good. Alright, you're almost there. What do I do for points? What do I do from here? To see if it's increasing or
You put it on
decreasing.
the number line.
Okay, so
Then
I
you
will
plug
put
the value in to the
0 and 3. What do I label this, Taylor?
That's f of x. No.
F prime of x. This is an f prime of x number line graph. Taylor, pick a first number.
Negative 1.
-1. Plug it in here. What is my sign?
It's gonna be positive.
Nope.
No, it's gonna be negative.
Pick another number. Let's go with Josh.
1.
Okay, now what would be my sign? Negative, yep. And let's pick a last one, Josh. What's the number that you'd pick? 4. I'm plugging it in here. What would you get? Positive or negative? Okay, positive. The reason why I asked Taylor what was this named is because a lot of people will plug in numbers in there.
Wait, why not?
That's not where you're plugging it in. I saw you just look up there just now. You're plugging it into the derivative function because you're trying to find the signs of the derivative. If f prime of x is positive, then this guy is increasing. If f prime of x is negative, then this guy is decreasing. Okay, know which one you're putting it into and why. Okay, so here we go. I will write, Jason, f of x increases on what?
3 to infinity.
Do I need justification?
Because f prime of x is positive.
Okay. You don't need it, but you can write it if you want. Notice I've never written it for those. Now you can write it if you want. F of x decreases, Jason, what?
From negative infinity to 0 and u 0 to 3.
Why did you not just say negative infinity to 3?
Because that's a critical point. Where 0 is.
And what's the derivative there? Is that positive or negative? That's why you're supposed to divide it up just like he did. Okay? So finish this up. Here we go. See if you have it. This is good. I've answered. I've got my critical points. My justification isn't necessarily needed on this because that goes with hand in hand of knowing that the first derivative and if negative is increasing, first derivative is positive. It's positive increasing, negative decreasing. If you want to write this justification here, just to be safe, so that you don't have to remember, wait, do I justify here or not? We're going to do it. Overkill it. No worries. Just make sure you overkill it correctly. Okay? Jason, finish it. Let's do number B, or letter B. Don't help him because you're giving him points. Relative what? Relative minimum where? If you get this right, I'll give you 2. If you don't, I'll take the one that you already have. Relative min where? Shh, or I won't give him points.
3 for x equal to 3.
Why?
Because it's going from negative to positive.
I'm going to give you it one more time. Well, why?
The signs are changing from negative to positive.
What should it have been that he said? Because f prime of x changes from negative to positive. We have 3 different levels. At x is equal to 3 because f prime of x changes from negative to positive. I'll let you do this last one, Jason. Relative min or max where? There isn't one. Why?
Because it doesn't, the f of x doesn't change from positive to negative anywhere.
Say it one more time because what doesn't?
Prime of x
F prime of x does not change what?
from positive to negative.
Perfect, okay? So relative max, none.
Can you say D and E?
You could say D and E if you want. Because f prime of x never changes from positive to negative. Good. He's missing one more justification though. He's got a point right now, but he's missing one justification. If you can tell me, I'll give you 2 points. There it is. Per, right here. This right here is per first derivative test. There you go. Per first derivative test, that's what that aims to find. Okay? On problems, and I'm going to tell you right now, a lot of people do this on tests every year. They just put per first derivative on every single problem. And you're going to get points deducted if it doesn't use the first derivative test. Okay? So please don't do that. Be very cognizant and sure of where you're putting that and why. Alright, who wants the next piece?
So does that make the whole kind of question wrong if you forget it?
The justification part, it's going to be taken off. Because there's 2 pieces of justification here. The justifications right here on the blue is this and that. Okay? Who wants to take the C? Who wants to take that? Anyone? Alright, I'll call on you. Mackenzie, we'll go with C. What do you do? Say again? You want to make a table from this? Oh yeah, you can look at your notes if you want. If not, just pass it to someone else.
Okay, I'll pass it to
Okay, anyone else? Bonus points. Go for Ian. Perfect. F double prime we need to find. Okay, here we go. F double prime of x is equal to what, Ian? Perfect. Keep going. What would you do next? Second equal to 0 and then factor out what? So you get x minus 2, right? Okay? So my critical points on the second derivative are what? 0 and 2. Cool. Okay? Now, what should I do? I'm going to do another number line. F double prime. Now, if you didn't make room, I do apologize, but I'm going to erase this. And this is what you should probably do for the test. Let's do F double prime line test. You ready? 0 and 2. Ian, pick a number. First interval. -1, what's the sign going to be after you plug it into your F double prime? It's going to be positive. So, pick 1, would you say? What's that one going to be? Anybody? Negative. And the last one, anyone? Positive. Here we go. Let's make some notes. Because again, the clearer this is, the better it is for you when you start to graph it. Negative means decreasing. What is decreasing? Good. F of x. F of x is decreasing. I'm over here on this. I'm doing everything at one shot. Over here, negative, decreasing, increasing. Now here we go. F double prime is positive. So it's going to be concave up. Okay? Or you could put F prime as increasing. Chances are the only thing that I'm going to relate if I'm doing it in this form is just concavity is all I'm trying to steal. Concave what? Down and then concave up. And this is F of x, right? So here we go. Yeah.
So you were talking about on the graph that there's a point where it would be neither. Would that just be like at the point like 0 and it's like at point 2?
Yeah, we're getting there. We're about to discuss about that here in just a bit, okay? Let's first find this 0 right here and this 3. What are the derivatives there? Like at 0, what was the derivative? What was the value of the derivative at 0? It was 0, right? Okay. That means it was what? Horizontal tangent. Horizontal tangent. So HT. At 3, what is it? HT. Horizontal tangent. Now let's discuss what Taylor was just bringing up. At 0 on the second derivative, what would that be? Point of inflection. That's it. Why is it a point of inflection? Because around this critical point, what happened? The second derivative changed signs. So this right here and 2 are points of inflections. Point of inflections are x-intercepts. Listen, if you can finish this. He says, are point of inflections x-intercepts on f of x? Yes or no? No. On f double prime of x, the point of inflection could possibly be a 0. Do you understand? Do you understand what I just said? On f double prime, like whenever we opened up today's notes with that f prime graph, if it was an f double prime, then this is a point of inflection, this is a point of inflection, and that is a point of inflection. You with me? Now let's go back and let's see if you know this. If this is, it was a good timing of the question. I like that too. If this is f prime, where are the points of inflection on the f prime graph? The x-axis? What'd you say? You said relative maximum. He said the x-axis. You said there's not any. If I'm analyzing f prime of x, and I said, okay, point of inflection, f double prime, sign changes. Either this or this. True or false? True. So that correlates to f prime changing from increasing to decreasing, which is here, just like he said, the relative maxes occur where? Or sorry, the point of inflections occur where? At the relative max and mins of the f prime graph. You see how you keep relating the differences? That's a huge one that people actually forget and they don't recognize. They don't recognize that at a max or min on an f prime graph, that's what's really going on. Alright, so let's go back. Whoops, not too far. So here we go. The intervals where f of x is concave up or down. Mackenzie, go ahead and finish that. Or who took it after she did? Who was doing it? Okay, Ian, go ahead and finish that. f of x is concave upward on, go ahead, negative infinity to 0, union, perfect. And concave down where? 0 to 2. F of x is concave down on 0 to 2. Finish it up with justification, Ian.
Because for the first one, f of x is concave upward on negative infinity to 0, you need to complete because f double prime of x is positive.
F double prime of x is positive. This is because what? And the other one is concave down because what?
F double prime of x
And you're almost done with your justification.
is per concavity?
Nice. For test of concavity.
Test.
For test of concavity. See guys, this is the hard part that I was telling you about. Knowing how to match up all the different definitions and the things that are defined in those definitions with your justification. Not second derivative test, even though you're using second derivative. Nicely done, Ian. Per test of concavity. And Ian, where were the points of inflection? So points of inflection at f of x equals 0. X equals 0. And 2. Why? Because what? F double prime changes signs. Done. Who cares if it's positive, negative, or negative, positive? Because you only have one type of point of inflection. It's not a max point of inflection and a minimum point of inflection. Okay? Because F double prime changes signs. Now, almost done with this justification. Ian, finish it up. What's the justification more on this? Not for test of concavity. For definition of point of inflection. Per definition of point of inflection, that's what that one would be. Okay? Now we're about to graph and then we're done. This is a lot for one problem, but I'm showing it to you for the first time. After that, you'll be able to go a little bit into autopilot mode and then understand what you're doing and how far to justify as you're going through it. Okay? Alright, so here we go. The last part we're going to do is we're going to actually graph this. And here we go. Let's graph this. I will make room, let's say, right here. And watch how I refer to my work as I'm doing the graph. Very first thing that I would do is I would look at f of x's of all my critical points. All of them. Okay, so let's in green highlight my critical points. 0, 3, 0, and 2. I said all of them. That means on the first, second, whatever derivative. All the critical points. So what would 0 be if I plugged it back into the original function? 0. What would 2 be if I plugged it in to the original function? Please use your calculator. Negative 16? Good. And what would 3 be if I plugged it into the original position function? You could do synthetic substitution. You could use your calculator, mental math, however you want to do it. Close. Put in your calculator if you need to, or write it down. Do the work on your things. Close. Negative 26, right? Am I mistaken? Is it negative 27? My bad. My bad. So, with negative 27, Josh is like, you. Anyway, let's plot these. 0, 0. Let me get a different color. 0, 0. 2, 6, negative 16. And here, let me do this. Exaggerate a little bit. 1, 2, 3. And then we'll put negative 16 way down here. And then negative 27 even further at 3. Okay? So here we go. What did I just do? I showed what they were defined. What I just eliminated are the opportunities of vertical tangent, oh no, not vertical tangents. Vertical asymptotes, removable discontinuities, okay? Or jump discontinuities, anything like that. So here we go. The first interval that I'm going to concentrate on is from negative infinity to 0. I'm going to decrease concave up until I come to a horizontal tangent. Do you understand? So let's decrease concave up until we come to a horizontal tangent. There's no guessing game. Now I know exactly how to do it. Okay? Now for the next one, I will decrease concave down.
Wait, but that's between 0 and 3, and that's between 0 and 2.
Good. So we're going to analyze between 0 and 2. So I'm going to decrease concave down until I come to what?
2.
No. Yes. No. A point of inflection. Until I come, that's what you said originally. Come to a point of inflection. So I'm going to decrease concave down until I come to a point of inflection at 2. Okay? Well, that. Now, here's the thing that a lot of people struggle with. If I were to get a vertical line, if you will, and combine these two, which ultimately that's what I want you to be able to do on this test. Put this as 0, lining up, best as you can. Here's 2, and then here's 3. So what we just did just now is we did, let me highlight it in yellow, this interval right here. We decreased, I know that's horrible, decreased concave down. What we're going to concentrate now on is this interval between 2 and 3, where we're going to do what? Decrease concave up. Because that's whenever this interval took the value of, ooh, it's going to be concave up because that interval was positive. So I'm going to decrease concave up to a horizontal tangent of 0 at x is equal to 3. And then forevermore at the very end, I'm going to increase concave up. We'll do more of this here in just a bit. You'll see it here with another example. And it looks like that. There's your graph. All right. The very first thing that I would concentrate on possibly is the first derivative, because that will tell me the critical points. So 1 is my critical point because that's my at value. And its slope is 0. That's going to be a horizontal tangent. This is an f prime of x. Now, everything to the left of this 1 is positive. Okay? Everything to the right of this 1 is negative. So already you should see a relative what? Relative max, because you're going from increasing to decreasing. So increasing, decreasing. Okay? Here, the only thing that you're getting from there are the position points, the position level function points. You have 0, 0, and you have 2, 0. So here's 0, 0, and here's 0. A lot of people got that, yeah. For the whole interval, my f double prime is negative, showing it's going to be concave down. So here we go. Increasing until I get to a horizontal tangent, concave down, is going to go all the way here until you get to 1. Decreasing, concave down, there's your answer. Okay, so for 10 points, you got that. The second one, here we go, for bonus points. Let's see if you can catch something. F prime of 1 is undefined. It's still a critical point. Okay, so here's 1. It is undefined. And when it's undefined, it can be several things. A cusp, an asymptote, vertical tangent. Here we go. 0, 0, and 2, 0 still occur as my points. To the left of this 1, I'm going to be positive increasing. To the right of this one, I'm going to be negative decreasing. The derivative is concave up throughout. Would you agree? Because the second derivative is positive, right? So how could I do this? Well, I have two options. I can increase until I come to 1, and then I can decrease concave up going through 2. Because, look, it's undefined. Another way that I could possibly do this is increase, someone said it, to a vertical asymptote, and then decrease like this. Do you agree?
Could you also have a cusp there?
So either one, cusp, I'm asking cusp or asymptote or both. Which one would you say?
But can't, so it's undefined though, so does it have real, like, definitive answer? It has to be cusp.
Why does it have to be cusp?
Because like the whole thing isn't undefined, it's just that point, right?
Nope.
It's in the domain.
How do you know it's in the domain?
Because it's a point, it gives you the point.
It could be undefined, it could be an asymptote.
Because it's on a continuous function.
There it is. Because it's on a continuous function, the only option that it can be is an actual cusp. That's huge. I give him 2 points. That's a huge one. It is a continuous function. It has to be a cusp. Yes. It can, but if it says this, it can't. Yeah, it can, but because it's a continuous, it has to be a cusp. All right, let's keep going. We still have more information to cover. Your last thing, or your last couple of things. All right, second derivative test is this. I'm trying to find relative max and mins. And I'm going to find them this way. Watch, if the first derivative is 0, I have a horizontal line. If the second derivative is positive, it's going to be concave up. They meet at this C, f of C point. So this is going to be a relative min. If f prime of x, or f prime of c, the derivative at c, okay, know what you're looking at. This is the x value at that point. If the derivative is now 0, but this time the second derivative is negative, means it's going to be concave down there. This would then be a what? Relative max. 2 different ways to find a relative max or min. You have to know both. Because of the questions, the way the information is given to you, you won't be able to use one versus the other depending on what you're given. Okay, so now if the derivative is 0, what would it be? Well, it says the second derivative test fails. You cannot determine this. We know if this is 0, f prime of x is constant, but we can't determine a relative max or min. We would have to then, I would use first derivative test. Okay, so here we go. This is my function. Using the second derivative, these are the kind of questions you'll be asked. I'm not letting you use the first derivative test on this one. Use the second derivative to see if I have a local max or local min at x is equal to -3. It looks difficult at first, but it's not. The only thing I have to first find is f prime of -3 equal to what? 0. Is f prime of -3 equal to 0? Well, let's figure that out. Deriving this, f prime of x is equal to 2x squared plus x minus 15. Plugging in -3 gives me 0. So that's check. That's good. The next condition is, what is the sign if I took the second derivative? You know what I mean? Is it positive or negative? So here we go. Take the second derivative. We have f double prime is equal to 4x plus 1. Plug in negative 3. You get negative, right? So this is negative what? 11? So f double prime of negative 3 is negative. Here's your justification. Per second derivative test, I'm not rewriting for the sake of time. For second derivative test, because this is equal to 0, and because f double prime is negative, there is a relative what? Max at x is equal to what? Negative 3. It's easy, right? It feels easy whenever you're looking at it with the information that you're given. A lot of people still depend on first derivative test. If you want to be one of these very few people, and I mean just statistically, that uses this, use it, and you can get the answer faster than when other people are doing that first and second derivative. It depends on the function. If you're given a function that when you have to derive it again, and it's difficult, it might be easier just to do the first derivative test. But if it's an easy function that you can just test, what is the sign of the second derivative, and is that first derivative 0, you'll know just like that whether it is. And you can use second derivative tests definitely if it doesn't tell you what to use. But do what you want. A lot of people still, even after saying that, will still depend on the first derivative test, which is still okay. Alright, so make sure that we have the justification. For second derivative test, f prime of 3 is equal to 0. F double prime of negative 3 is negative. Therefore, there will be a relative maximum at x is equal to negative 3. Done. Yes?
When you're writing your justification, you have to put f prime of negative 3.
Yeah. You have to explicitly, you can't put f prime of x. It has to be of negative 3. Okay, here we go. Using the second derivative test, we're going to do it a little the same. F prime of x is equal to, anybody?
2 sine x minus 1.
Good. 2 sine of x minus 1. F double prime is what? 2 cosine of x. So here we go. All we have to do now is just plug that in here and here. What's the sine of pi over 6? So that's the y value. 3, 2, 1, 3, 2, 1. Ooh, we might need a unit circle pop quiz soon. 1/2 times 2 minus 1. What's that value? 0. So f prime of pi over 6 is 0. Check. What is cosine at pi over 6? Square root of 3 over 2. There you go. So multiply it and you get what? Square root of 3 or a positive, right? So f double prime at pi over 6 is a positive number. So it's going to be a relative min. Because this is concave up, this is horizontal tangent, we can say per second derivative test, because of this criteria, therefore relative what? Min at x equals pi over 6. Done just like that. Okay? We still got some more. I want to make sure that I get it on the video, so if you need to at a later time, go back to this. Please do refer to it.
Where will this video be at?
This will be on the playlist online, the student resources on the playlist on YouTube channel. Here we go. Second derivative test. If possible, we're going to do relative extrema. So immediately derive twice. F prime of x equals 6x squared plus 6x minus 12. F double prime of x is equal to 12x plus 6. And the difference here is they didn't give me an x. So I got to set it equal to 0. And I have to find these critical points. So here we go. Good. 0 is equal to, watch, I'm going to factor out a 6. And then I'm going to factor out this trinomial. What are your critical numbers? Negative 2 and 1. Here we go. So negative 2 and 1. This is f prime of x. F double prime of x. What's your critical point? Negative 1/2? So x is equal to negative 1/2 is about here. Do you see what I'm doing? Alright, so now I'm going to grab and make this a little bit clearer than what I did that last one so you can understand what's going on. I'm trying to put less, what's it called? Highlighter. Here we go. So I have, here are my critical points. Negative 2, 1, negative 1/2. Here you go. Where these are zeros of the function, what is their derivative? What's the derivative at, what's f prime of negative 2?
0, 0.
Yes, f prime of negative 2 is 0. What's f prime of 1? 0. Okay, so now what's f double prime of negative 2? Look where it lies. We need to do a sign test, don't we? Okay, so here we go. Let's do a sign test on f double prime. Remember, here is your line, your critical number. So something to the left of negative 1/2. Negative 1. Put it into the derivative function. What do you get? Negative. So this whole thing, right here, this whole interval is concave down. You see it? Now something bigger than 1/2. Negative 1/2, that is. 0. What's the sign of that? Positive. So that means this whole interval over here is going to be what? Concave up. Do you see it? So f double prime at negative 2 is going to be what? F double prime of negative 2 is going to be negative. Or concave what? Down. F double prime at 1 is going to be concave up or positive. So here we go. Justification. Let me finish it up real quick. Per second derivative test, relative what? Max at x equals negative 2. Because that's where it's horizontal tangent with concavity down. There's a relative max. Where's a relative min? The other guy, right? At x is equal to 1. And all your justification is there. No, not negative 1/2. Negative 1/2 was not a critical point that would show a relative max or min. That was just where it showed what? A point of inflection. A point of inflection where the concavity changed. Okay?
Mr. Jones,
Yeah.
for a problem like this with tests, will we need to be prepared to probably finish off the problem and draw the graph?
Yes. For the most part, the ones that have functions, be able to draw the graph is pretty much it. If you're there, you know what I mean? And like in your notes, what we're going to do here, we're going to do this example, and then I'm going to go over limits of infinity with the time that we still have left. And this last 2 pages, not this, even and odd, right here, this problem with 7 parts, and this problem, an actual AP question, is what I will record and have you watch over the weekend just to, if you want extra practice. But these 2 slides, let's go ahead and finish the notes. Here we go. I want to determine whether f has a relative max or min here, or neither. I have f prime. So what could I do if I have f prime? I can do the first derivative, but the only thing bad about that is that I don't have a function for what? G of x. So if I use second derivative test, it might be easier. So f double prime is the first times the derivative of the second plus the second times the derivative of the first, and it's all evaluated at what value? 3. All those are 3's. You ready? What is g of 3? Negative 2. 3 6 minus 1 is 5. We have 9, we'll have 0. And g prime of 3 is 7. But this goes away because it's just 0. What's the f double prime of 3? Negative, right? It's negative. Because this is negative, and this one, if we plugged it back in, which it would work out, we'd get 0. That would be a relative max. Because it is concave down, being negative for the second derivative, and it is 0 as far as the slope there for this first derivative. And I think I am about out of time. No, it brings up what time? 48? Oh, it's got 5 minutes.
We got 4 minutes.
Okay, here we go. That's still enough time. Limits of infinity we've done before. This is a review for limits of infinity. Here we go. Watch the review. The thing that I asked you to do a long time ago when we did this was I said, hey, if you wanted to, you could use this justification. Well, here's the thing. You can if you're doing multiple choice. If you're doing free response, and I don't know if you remember this, a former student from last year, T, sent me a text saying that her professor said you're getting these answers way too fast. You need to show your work. She was getting them so fast because she was using the shortcut. But I wanted to make sure that you understood how to show work, and this is how work is shown. Okay? I always go to the denominator and I find the biggest degree of x. So if it had like 3x squared plus 2x plus 5, I would use the x squared. Okay? And everything that you see is going to be divided by that thing that I just pointed out as far as that x value highlighted. So here we go. 1 over x. The whole thing is 2x over x. And what do I do before applying the limit? What do you remember me saying long ago that you should do before applying the limit? Simplify. Here we go. Let's simplify. This simplifies to 3 minus 1 over x over 2 plus 5 over x. Now we can plug in the limit. What does this become? What does 1 over infinity become? It becomes 0. 1 divided by a huge number becomes a small number. When the bottom is increasing way faster than the top is, it's going to converge to a 0. And you can use Bobo there if you want. But this is the work shown. This will also go to 0, so that the answer is 3/2.